Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a problem on loss of head due to entry and exit in a pipe. In our previous video lecture, already we have discussed regarding the theory of loss of head due to entry and exit in a pipe. So in this video, we'll see how to solve the problem related to entry and exit in a pipe. Determine the rate of flow of water through a pipe of diameter 20 centimeter, length 50 meter, when one end of the pipe is connected to a tank and other end is open to the atmosphere. So one end is connected to the tank, another end is open to the atmosphere. The pipe is horizontal. The height of water tank is 4 meter above the center of the pipe. Consider all minor losses and take F equal to 0.009 and the formula HF equal to 4F LB square by 2 dg. So this is already given, like the formula is already given. So for that, what we'll take first, let's try to draw a diagram. A normal pipe is given. Suppose this is the pipe is there, and whose length is given already 50 meter. So from here to here it is 50 meter is there, and diameter also given, I hope. Yeah, diameter 20 centimeter given. So this is through this pipe, actually through this pipe the water is flowing, and the water is coming from a tank actually. Okay, and one end is open to the atmosphere, so we can say this is the end where the water is existing or water is going out to the atmosphere, and this diameter is given 20 centimeters, so we can write 0.2 meter if you want to convert. Now this is connected to the tank, connected to a tank. So here we'll draw a tank to this one. So let connect like this, and this tank is filled of water. Yeah, so we can draw like this. Yeah, it is filled of water is there. Now this water level, actually this water level is the pipe is horizontal, height of water in the tank. So up to what level the water is present, 4 meter above the center of the pipe. Suppose let me draw the center of the pipe, like this is the center of the pipe. So this water level is situated then with a height of 4 meter. So this is the height 4 meter is here. Okay, so these are the data given, and all losses we need to consider. What are the losses may be possible in this? We need to consider the losses, and we need to find out the rate of flow. Okay, and F also we need to consider. F equal to 0.009. So first let's write down what are the data given for this, then we'll go for solving the problem. So here the data given is, we can write diameter is given. So D is given 20 centimeter, and this one we can write in terms of meter, that is 0.2 meter, and similarly length L given 50 meter. So this is length, and next is given height of water, this is H given. So H given, suppose 4 meter, and next is given F, the value of F given, this is coefficient of friction, we can write 0.009. Next the formula is given for us. F equal to, we know that 4F LV square by 2 dg. So this is the formula of major loss. So major loss, why we consider? Because it's consider all type of minor losses is told, but here also we can get some kind of major loss when it is flowing through a pipe, when the water fluid is flowing through a pipe. So that's why it is also considered. Now we need to find out the rate of flow. So before going to the find out the rate of flow, let's consider two different layers. So this is the top surface of the water. Let's consider this is one layer, okay, water surface, and where the water is existing. Okay, so this is one layer. This is one layer, means this is one section. So let's consider this is section 1, and let it consider this is section 2. So now between this section 1 and section 2, so this is the center line, and this line also can be considered the datum line of this fluid. So like by considering the Bernoulli's equation between the section 1 and section 2, so we know that Bernoulli's equation we can write here, and that is the equation is P1 by rho g plus V1 square by 2g plus Z1 equal to, here we can write this is P2 by rho g and V2 square by 2g plus Z2, and what are the losses will be there in this pipe flow. So we can write all kind of losses which is present in this fluid flow, minor as well as major also. So now we can put the value of all this, what are the values are given this. Now here if you see, this is at the surface level, we have the, like, you know, atmospheric pressure is there, and here also when it is leaving to the out to this is also pressure, atmospheric pressure is there. So here we can consider the datum line, this is the center line, we can consider the datum line, and so that Z1 height will be this one, and Z2 height here it is, there is no Z2 height, that means 0 at this level, section 2. So what I can write, this value, let's put it 0, okay, and there is no flow in this particular point, let's keep that is also 0. But here the datum head is given 4 meter, that liquid is situated at the 4 meter head, 4 meter height, so this is 4, and similarly the pressure head at this exist point also not there, so that means we can consider 0. Again V2 square by 2g, so what is the velocity of this fluid, it is given, then we need to write the velocity value. Velocity is not given, we need to calculate it, so only write the same equation, V2 square by 2g plus Z2 also here 0 is there, Z2 also 0 is there, and now we can write what are the losses are there, all losses what I told you. So in the all losses we can consider, one is loss due to the friction factor, or the loss through the pipe which is flowing through the pipe, that is HF, and next one we can consider the head loss due to in the entry in the pipe. Okay, these two things we can consider. Now finally what we can write here, we can write E2 square by 2g plus HF plus HI equal to 4. Okay, these things we can write. So now we can write one thing, the velocity of the fluid in the pipe also we can consider here V. So they equal V equal to V2. So what we can put here on the value of V2, you can put V also. Okay, so this is nothing but we can write V square by 2g. Why I have written here V2 in place of V2V, actually when it is existing here, the same, that is the velocity in the pipe. Okay, the same velocity is coming out here, that's why the V in place of V2 V kept. So this one is equal to 4. Now we know that actually, now previously if we have solved already, we know that HI, the head loss in the inlet, equal to 0.5, okay, V square by 2g. This one already we got in the previous theory part and derivations, because this is expansion is there here, sudden expansion, sudden contraction is there. So due to that we got this value 0.5 V square by 2g, and HF value already we need to consider, that is again different equation what we have considered there. So we need to find out the Darcy-Weber's equation what we have taken there. So based on that we need to find out what are the friction factor already given, length given, velocity need to be calculated, velocity need to be identified. So remaining things are given. So what we'll do, this is HI and this is our HF. Okay, so these two things we can put in the value in this equation. Actually this is the equation, we can put this value. Now after substituting the value we can write, yeah, let's write here in this equation. So substituting the value in this, we can write 4 is there in the, suppose let's take it in the left hand side, and V square by 2g plus 0.5 V square by, again we can write this is 2g, and next we can write 4f LV square by 2dg. So these are the values are given. Now here, how many v square are there? You can consider this v square by 2g common from all these points. So what will be the final equation? We can write here 1 plus 0.5 and plus 4, f value is 0.009 into length is 50 and divided by 2d, 2 into diameter 0.2. Now 2 already we have taken common, so this is not required. 2 is not required, only d is 0.2. So this is all about the value here. Now here we can find out here what we can write this value 1 plus, so let's solve this one. This is 4 into 0.009 into 50, 1.8 divided by 0.2, so 9 plus 1 plus 0.5, that means 10.5. So we can write this is 4 equal to v square by 2g into 10.5. So what is our intention? Our intention is to calculate the value of v. So write down the v square equal to 2 into 2g, 2 into 9.81, and this 10.5, let's divide in this side, this is 10.5. And finally, if you want to calculate the v value, so you can write v equal to root over of 4 into 2 into 9.81 divided by 10.5. Okay, so now we can again calculate this value. So this is 4 into 2 into 9.81, so 78.48, so divided by 10.5, 7.47 root over of this, so 2.734. So we can write v equal to 2.734. This is meter per second. Now what we need to calculate? Finally, we need to calculate the rate of flow actually. So we know that rate of flow q equal to, we can write a into v. So a is nothing but pi by 4 d square. So we can write pi by 4 into 0.2 square into v. V is nothing but 2.734. So all these things if we calculate, we can get the value. Now this is already there, keep it. Now 0.2 into 0.2 into pi equal to divided by 4, 0.085, 0.0858. So this one we can write 0.0858. This is meter cube per second. So this is the rate of flow in the pipe. Okay, this is the final answer. So I hope you understand this problem, how to solve this kind of questions when it is losses of head in the exist and entry in the pipe given. So here also actually you can see both the conditions are given, like entry and exist also given. Along with that also there is a loss through the pipe flow. That means the major loss need to be also considered here. So this is not that much difficult, it's simple. So I hope you understand this theory and this problem, how to solve this this kind of questions. If you're having any kind of doubt and query regarding this, you can give a comment on the comment box. Thank you.